Hi, everyone. Thank you all so much for joining today's webinar on atomic architecture. Our speakers today are Malcolm Sparks, CTO and co-founder of JUXT, a software consulting company that was formed in 2013. Malcolm has 3 decades of industry experience. He has led software development teams, spoken at numerous tech conferences, and founded several technology companies. Alongside him is Jeremy Taylor, head of product for XTDB, an open source database for solving complex problems with dynamic and temporal data. Before joining JUXT in 2019, Jeremy held a sales engineering position within IBM, working on e-commerce systems. So without any further ado, Malcolm, the stage is yours.
Thank you, Adi, and hi everyone, and welcome to this webinar. I know we have a mix of beginners and experts, and so I want to appeal to you. If you're a beginner, there are no questions that are too basic. Actually, I'm more scared of the hard ones. If you are a seasoned expert in software architecture, we'd love to hear your views and perspective. If they're not the same, we rarely all agree on any given topic, and I think that makes it more interesting. So Adi gave me a nice introduction. I'm just going to put on one slide the languages that I've come from. In the 80s, I was a kind of child growing up with home computers, and so my earliest computer was the ZX81. And in those days, there was just 2 choices. You had BASIC, which was super easy, and then machine code that was super hard. But then after college, graduated onto languages like C and C++. And then very early on, when Java arrived, I was kind of an early adopter, and I chose Java as my go-to language, and so spent many years building Java systems. And then in the last decade or so, I gravitated to a functional language on the JVM called Clojure. These are the projects that I've been really working on over the years, and this kind of should give you a sense that I'm really interested in the web, APIs, making things secure, and particularly back-end systems. So this is mostly a talk about the back-end. So I founded a company with John Pither called JUXT in 2013, and we have Clojure and functional programming roots. Most of our work has been in web development and information systems. So a motivation for this talk. This talk, I think, is timely. We're in something that I would characterize as a worldwide IT complexity crisis today. We're building hugely complicated and insecure systems, and leaving the maintenance of these systems to our children and our children's children. So that's my emotional appeal as to why this topic is very important. I'm going to cover atomic architecture as a list of 7 principles, and we'll go through them one by one. And there'll be a short exam for you all at the end. So without further ado, I'm going to explain the first principle of shared state. So there's a really nice article, a few articles in a series I came across about a month ago from Andres Gerlitz. And Andres makes a point in one of his articles that for the last decade or so, we've been moving as an industry away from these central SQL monoliths in an attempt to separate concerns and to simplify. You see, central monoliths were complicated, brittle, resistance to change, and anyone who worked on them on a large system will recognize this. I was on a system once for British Telecom with about 250 engineers all working against the same single database, and it was a nightmare. Microservices came along and really gave the developers a way to break out of that inertia. It was a green light to start building stuff again. And really, just as the way the word waterfall was invented as a kind of mythical monster to define agile, the term monolith has come along to characterize, invented by the microservices community, to characterize this problem of having everything all packed together in one system and being incredibly difficult and torturous to change it. So our central thesis, however, is that the complexity that was characterized by these big SQL monoliths, hasn't been reduced. The decoupling hasn't happened. And as we shall see, the complexity has become compounded. So another article that Andres wrote in the series, and this will be in the email we'll send you after the webinar, and I really recommend you read this, because this kind of explains why the simplicity offered by having lots of little different independent services is actually illusory. That many of the problems that come about with microservices is due to increased coupling or coupling between the services, services that require data from another service, or data that decisions that are made without access to all of the data, the distribution of state, the problem of time. There's a quote in his article saying, in distributed systems, there's a difference between the time you gather the information and the time that you rely on the information that you receive to store the data. So there are implicit dependencies between services that break the independence of each service. Plus, processes are allowed to happen in parallel, which means that you get errors and you have inconsistencies. And I have to say, when microservices came along, I was initially a little bit against. I've come from, I did a lot of work in the early noughties on Corba systems, and this for me looked like, I've seen the problem of having lots of distributed services everywhere. And I thought this problem was really to do with the network, and the network not being reliable. There was a good paper called The Fallacies of Distributed Computing, which really explained that the problem with distributed computing architectures was really that you can't rely on the network. And yet networks are a lot better than they were back then. So after some thought and reflection, I've come to realize that the problem I really have with microservices and the architectures is the management of mutable state. So I need to explain that. With procedural languages and scripts, we weave this thing called mutable state into our program without much thought. With object-oriented programming, we kind of encapsulate this mutable state, but into our objects. And now these objects are scattered across our program's organization. And if we extrapolate from having objects with mutable state, we end up with distributed services that have mutable state. And all of the problems with distributed mutable state in object-oriented programs are amplified when we scale them out to network microservices. So the state of the system is just the sum total of all the records in all the various databases, all of the messages queued up, messages flowing over HTTP between services, and the in-memory state of each microservices, and so on and so on. So with functional programming, however, we try to write our program as a set of pure functions. So this has really influenced me as an architect. How does functional programming, what does it have to say about architecture? In some, for example, I was inspired by working a little bit on the UI. There's a library that we use in the Clojure community called Reframe. And this is really, it shows how it's actually a flow of pure functions. You click on your UI and it creates a message, and that gets dispatched to an event handler, and it's handlers until it gets to some state, which is this blue ellipse. And that state has the entire state of the application. And then we make a single function that is going to take the existing state and create a new state. And that will trigger the refresh of the UI. This style is called functional reactive programming. And it was a real influence on me on thinking about state in systems. Now, the state in Clojure in this little front-end application is called an atom. We have a facility in the language called an atom. So that is really the container that stores state and manages the successive application of functions in a serialized fashion. So the atom, the name atom, is what inspired the term atomic architecture. So at the heart of an atomic architecture is an atom centralizing our state. But we're going to replace our atom with a database or even a set of databases. How far should we scale this? This is a big question. I hope we can have some discussion at the end. Facebook have scaled this to their entire company. It's implemented as a huge cluster of MySQL databases in a system known as Tau. But not everyone is Facebook and has their scale. And I think the right granularity for this is what we might call the domain or a department. In her work on data mesh, a book by Zhamak Delgani, she borrows a term from Eric Evans in domain-driven design called domain-bounded context. So this is large enough to span multiple databases and applications and services and teams, but it's where everyone can agree on a common language or a common data model. I think this is kind of related to Dunbar's number, which is this idea that humans can only maintain 150 stable relationships. And I think this is a nice upper bound. So that's the kind of size that we're talking about. Now, for many domains, the database isn't going to be the bottleneck, but the amount of data or whether the database cluster can scale is going to be a key consideration. So in helping me prepare for this talk, Jeremy sent me a link to this article by a program in Finland, explaining that coming up with a single central schema or language is actually this is the heart of the problem that we had with SQL monoliths. The problem with everyone sharing the same schema is that we reintroduce the same couplings that we're trying to avoid. Systems that force a common schema on everyone causes havoc when you have to change that schema later on. The schema evolves, and then you ripple this kind of database schema migration. Everyone's affected to it. Everyone has to recompile their applications, and that causes this kind of extended blast radius. And we really want to avoid that. We've also had in JUXT a number of conversations and real projects around event-driven architectures. And a lot of the debates and a lot of the problems actually stem from getting everyone to agree on a single data format for messages. And when that changes, you have all of these horrible migrations to do. So we want to avoid that entirely. So we're not going to do that. And I was trying to think of an analogy for this. And I often use the word student kitchen to illustrate what it's like when you have tons of people all trying to do their own little thing, but in a shared environment. But when I Googled for student kitchen, actually, student kitchens seem to have improved a great amount since I was at college. But the idea is, I'm afraid you're going to have to do without a visual prop here, but you'll have to use your imagination. Anyway, that's about shared state. We're going to avoid the problems of shared state by trying to reduce every change that we want to make to the system as a domain operation. So this is the second principle of atomic architecture. So what we do is we try to divide up everything that we want to be able to do in the system and give it a business name. This is definitely an idea which we've drawn from domain-driven design. If you want to see a parallel here with CQRS, which is Command Query Resource Separation, these are really the commands that are going to change the system. So each operation is applied consecutively to the database. And this, in the kind of functional programming world, this is a there's a nice quote by Alan Perlis saying it's better to have 100 functions, or 100 operations in this case, operate on one data structure than it is to have 10 functions operating on 10 data structures. So this brings us to a third principle. So just see if there's any questions. So we have our shared state now. We are able to then run our operations which are going to change that state, and we're going to do that one after another. Each operation, though, in this case, gets to work on the very latest state of the database. And this really is what brings back simplicity to our state management, because there are so many problems when you elect to have eventual consistency, or you elect, trade consistency for availability in a distributed system. All kinds of inconsistencies can crop up. For example, it's possible to have multiple bookings for the same dental appointment for the same dentist, or it's possible to order a product that no longer exists, or overbook a plane, or all of those issues to do with inconsistency have to be managed. There has to be code written for, it has to be thought about, and the error cases have to be handled. And any of these error cases that are really caused by operations not seeing the very latest state. So for example, if you have an operation that is checking the number of products that you have available in your warehouse, if that's working on out-of-date data, then you might decide to ship a product that you no longer have. So the opportunity of running things one at a time is brought back by the fact that we've centralized everything, because the speed of light, it's just better if you can run operations at a center. Then if you need to lock or anything, those locks are going to be not subject to kind of long latencies that you get with distributed systems. So it's an opportunity. And I was thinking about this as, where have we seen this before? What is the prior art for doing it? Now, the earliest prior art that I can think of is actually the old mainframe. In the very early days in the 60s, mainframes ran off punch cards. You would write your operations on punch cards, and the system would process these punch cards one at a time. The remarkable thing is that actually many business processes ran on this, and these machines weren't all that quick. And yet that was the discipline of running these jobs one after the other. In fact, when multi-processing systems came out that allowed you to do jobs in parallel, this property of consistency was potentially going to be lost. And it was considered so important that IBM and other companies invented the idea of a transaction. They invented this concept in order to create the illusion again, or the perception, that you were actually processing these jobs one after another. Now, of course, there are some issues with this. One immediate of doing one thing at a time. Kind of the delays that you get in airports because people go through the detector, one at a time, and that slows everything down. I would say that there is two mitigations that I would have, or two responses to people who say, "Hey, this Malcolm, this just doesn't scale. We've tried it." The first thing is what we do is it's very important to break categorize the operations that are going to do writes with the operation that are really queries or reads. And we say that certain times it's okay for certain operations to query off old data. They don't need to query the very, very latest database. So if we have that situation, the reads can be put out to a read replica or a clone or a cache. They can be scaled out. The most important ones that we want to funnel through one at a time are the operations that are going to make changes to the state. So that reduces the number. The second mitigation that we can do is we can write our operations so they're asynchronous. So for example, we can add a transaction to a bank account. We can book a room without knowing exactly. We can put a room booking request into a queue, and we might be able to write our system in such a way that we can wait for a delay. We can wait 5 minutes or so. And in fact, the entire banking system is built on this very premise that operations eventually will have to be reconciled at the center, at the automated clearinghouse. And technologies or things like faster payments are actually these little tricks, this little bit of magic that gives you the perception that you've received money in your bank account, whereas in fact, it is possible that that money can evaporate and disappear if the transaction at the automated clearinghouse doesn't clear for any reason. So there are ways and mitigations of making sure that potentially a queue of operations are you can build big systems on these, and especially if you can get the operation rate to be, if you can get up to tens or hundreds per second, then you can do tens of hundreds of thousands of operations in an hour. Okay, so I would also, just a little fun fact, that the Postgres database by default doesn't give you this pure serialization property, and in fact you can enable it, but by default even Postgres does suffer sometimes from these inconsistencies. Okay, so we're just going to take a little break now to have a look at the Q&A. Okay, so Henrik Peterson says shared state consistency problems go a long way to explain the rise of Flink. So Flink seems to be solve this problem. Yes, and I would agree. This is what's so encouraging about the popularity of things like Kafka and Flink, which is kind of a stream processing queue where you're actually putting things into linear order. Yeah, I agree. And in fact, this atomic architecture, we haven't really got strong opinions of what components you use. We'd really like to get your feedback as to which components you can put together and assemble to create kind of an atomic architecture with these principles. There's no standard set of components that we're really we've got strong opinions on. So we have a question: how can we use this approach when creating read models for our views? Are your domains large enough that a certain view will only be sourced from a single domain, or will we run into trouble when trying to construct views sourced from different domains? I think the modeling and the domain modeling is one of the questions of trying to get everybody to almost allow multiple domains to go into the same area, the same database, without conflict or without clashing. There are definitely some ideas from the knowledge management community and RDF that have thought about this problem for a long time, where you can avoid domain clashes. So you can say, well, a JSON keyword or a column called amount means this thing exactly, which is this domain, rather than the ambiguities that you get when you merge domains together. So things like JSON linked data and RDF do have a lot of things to say about this. But yes, in answer to your question, I do think that we're talking about being able to construct views that are sourced from different domains, only that we're strongly encouraging this idea that you have one single source for your entire domain. Harry says, eventual consistency is a feature of the real world too. Your warehouse management system might say that product is in stock, but in fact, somebody has nicked the last one off the shelf and damaged it. That's exactly what happens in the real world. But I believe that IT and technology is meant to give us solutions that are simpler than the real world. It's meant to be actually a tool to help us have more rigor in life and simplify our lives. And so the fact that eventual consistency is a feature of the real world, I think we want to use our technology to abstract away from that. The scientific equivalent in atomic architecture from Joseph Winston that says I contend is Fortran, common building blocks of subroutines that interact with the atom in specific and known order. I've seen and worked on Fortran systems that are as old as the Fortran 4 compilers, are measured in 100 million lines of code, and that are 60 decades old. Now, I've never programmed in Fortran, so I'll have to take your word for it, Joseph. But I do know that there are many systems that are still alive today doing very, very critical processing, and they must have got something right. And I believe that these ideas of consistency are very, very old and were discovered a long time ago. My concern is that many of these principles have been sacrificed prematurely on the altar of performance, availability, speed, time to market. And in fact, in the long future, this is actually very detrimental to us. And this is why I talked about this kind of burden of managing and maintaining these systems by future generations. I think we really need to get back to some of the simple key principles that survived. And I definitely want to have a look at this Fortran common blocks. Okay, and Henrik again says the concept of shared state, however, does not seem to be very compatible with data warehouses and BI tools. Schema changes to a shared state might be a solution for service interoperability, but how about the OLAP stores where schema changes also cause havoc? Well, yes, that's a very good question. That's a very good point. I think what we're doing was we are focusing on this talk more around operational and transactional data. I think there are definitely a lot of problems with the constant ETL pipelines and the mapping and in the OLAP community. Lots and lots of scripts and a lot of hand weaving and wrangling of data, where some of the principles of disambiguating field names, knowing what exactly column names mean, and this kind of blending together is very important. Thanks very much for all those questions. That's great. Going to go on to the next question now. Next principle, which I call API only. It's related to this idea of API first. I do believe that in a modern system, the only way that you should be able to affect change in the system is via an API. And so what I suggest we do is we take an API specification like OpenAPI, and where we've got this kind of ability to say this get on this endpoint is this operation, we put in the name of the domain operation that we want to call. The reason I think that's kind of important is because it allows us to build a system where every service, every application, every party, everybody who interacts with that system does it in the same way. And it allows us to create a contract with the rest of the world. I think one of the big problems with systems is this problem of schema migration and the effect it has downstream. So I think that rather than create a shared model and allow everybody to sort of jump into it, you really do need this extra level of indirection where you can keep the API absolutely stable, keep the operations that you're exposing these operations to an API, and then if you make changes to the shared state, then you only have to make changes to the operational implementations, and you can keep the names of the domain operations the same. I think in case where you really do have to change the appearance of an operation, what it accepts and what it produces, then you would just create a new domain operation for that. So you're trying to use the API to give you maximum compatibility. And I think there are some things there's not many things in IT that become hugely popular that are also really, really good. But I personally, I have a personal point of view that I'm really glad that REST seems to, or JSON and HTTP seems to have won out, and the web won out over some of the more enterprisey stuff. Some of the things from other things from W3C, the WS Star set of services and Corpora and so on. I think there's some fantastic features within HTTP. I think it hasn't been kind of fully realized or fully exploited. I also think JSON is absolutely an excellent data format compared to many others. I'm so glad we've arrived at something that we all share that is a nested data structure, which is incredibly simple, simply just a set of objects, maps, collections. I think that is absolutely fantastic. So I really love the fact that APIs have come in to become so popular. In fact, but I think 90% of the internet traffic that there is actually calls between apps over JSON over to backend services. I make this point about APIs and about the importance of creating real public APIs. I saw this kind of work pod at a motorway service station not so long ago, and there are hundreds and hundreds of startups like this in the US and Europe and all over the world, where single companies have to create an entire vertical integration where you have to make the app, which you have to download onto your phone, and that calls some sort of account system, or that gets you to put your username and password in there, or you create an account, and then you have this ability to call or unbook a meeting pod, and it will unlock with the firmware, which is all fantastic stuff. But well, why do I have to download an app and have yet another app on my phone? If there was a public API, then surely I could access it through my Google Calendar or through another app. And we're sort of seeing this more and more. Instead of having lots of vertical integration, we really want to use APIs to allow a kind of amazing explosion of services. And this is how this is what we're trying to do in open banking, for example. I mean, this would almost be like open meeting pods. Why isn't it possible to book a WeWork or any serviced office just from any other app that you choose? If you compare this with, I think, one of the most successful interface products that I've ever come across is the bayonet light fitting. And this is kind of story about the bayonet light fitting came from a kind of pistol that was kind of left over, I think it's of the British Empire. It was all around the world. British Empire was the biggest empire around the world, and had and when they discarded all the rifles and there were all these bayonet fittings, and so somebody figured out that actually this would make a really good interface for the light bulb, to actually have a bayonet thing that you could screw into this thing. And it just meant that because the bayonet light fitting became so popular in the countries that adopted it, it completely meant that you didn't have to buy the bulbs from when you bought a lamp. You didn't have to buy bulbs from the same lamp vendor. You could buy bulbs from whoever you liked, and it would plug into any lamp. And this kind of sense of like opening things up through having a very, very strong interface is really, really important. In fact, I think if we can get to the point of actually making APIs secure, then we have this opportunity to directly connect our mobile apps and browsers to these applications without going through these what was called BFFs, these servers that just sit there just in order to front a mobile app or a web front end. And their only job is to kind of act as a sort of gatekeeper to the database. And at our 10-year party, I talked about, well, why can't we just get rid of all these things? So the thing that's stopping us is this ability to create APIs. So one more thing I want to say about APIs, and that is that the original problem with security was that you can't, an application used to ask you for your username and password, and for very good reason, we should be reluctant about giving apps our passwords. The technology OAuth 2, which is another one that is just a really, really good yet incredibly complicated technology, has actually been adopted virtually wholesale by the industry. And this allows humans to delegate their permissions to applications without giving the application their password or credentials. And I think this is an absolute game-changing technology, not just on the internet, but hopefully in terms of putting this into organizations, allowing domains to own their own security. And so for human-facing applications, the human can contribute to the authorization of these applications and limit their access to critical data if necessary. So this is something I think is a real kind of missing piece to internal APIs. And yet, OAuth 2 is only a delegation protocol. where users can authorize applications to act on their behalf. But that's only half the story, because the second half is deciding what these users or autonomous applications that aren't acting on behalf of users, what are they themselves allowed to do? And this is where I think that access control is really a key principle, because it's very, very difficult to do authorization in a third-party service. We can do authentication really, really well, and there are many, many examples of OpenID Connect providers and identity providers that you can just drag and drop, bring into your organization, and they work. There's a difference with access control, because access enforcement policies often need to access the domain data. It's not just about users and roles. Sometimes we need to work on make enforcement decisions based on the metadata of the things in our database. So how do we know what is data and what is metadata? We might store a document with an owner. Now we need to know the owner of the document. So we need to look into our database, and the owner may have shared access. They may have decided to share access to the document with their colleagues, but only in the same department. How do we enforce this access? How do we make sure we have enough of the relevant information to enforce this access? Or how do we make sure the relevant information is actually current? These are really hard problems to do in a third-party service. So my answer to this is to move the functions that enforce access control closer to, as close as possible to the actual data they need. Actually put this access control beneath the APIs over the, and even I think in this diagram perhaps doesn't really, isn't really the right place to put access control. It should even be below the operations. So the domain operations are subject to access control. So that's my answer. Move the functions that enforce access control closer to the actual data they need, and make access control enforcement the responsibility of the domain. I think there is a move towards this already. There was a big breach in Google in 2009, and Google were compromised by a very organized attacker who got past their firewall. In response, Google realized that it wasn't sufficient to merely secure the front door. They had to lock all the internal doors of their house. So that way, if an attacker breached the firewall, it was much harder for them to steal the data from all the internal systems. So in the last decade or so, more companies have decided that it's just too complicated to centralize all your security. Firewall exceptions get added, they never get removed. It's just too risky to remove firewall rules when you're running critical systems, when you have high staff turnover. So as we build a new generation of systems in the future, we have to build access control, not delegate it to the security department or the security operations center. We need to allow our domain to own the security, because it's the domain that know what the security rules and policies should be. It's the domain that knows what the language, what the commands actually mean and what they do. So it's very, very hard for a central security organization to know what the firewall rules should be. So I do believe that we're looking at a kind of decentralization of security as the technology becomes more accessible. So we've got a question here. If the API-only principle implies a one-to-one relationship between domain operations and API calls, how does the atomic architecture handle operations that may trigger other domain operations? That's a really good question. For simplicity's sake, I don't really know the answer to that question. I think this talk is perhaps creating by intention an overly simplistic architecture in order to tease out discussion, get people thinking. I think this idea that an operation might trigger other domain operations, we are actually building some reference implementation, if you like, with our product set in JUXT. And I personally have chosen that a design where domain operations can't call other domain operations. I've just decided that isn't possible, and I'm happy for there to be a degree of duplication of code, I suppose, in a particular operation. The fact it can't call another operation means it has to kind of do everything itself. I think there's some benefits to that approach. It means that every operation is independent of each other, and domain operations can be just left alone to do what they do. They can't, if you have dependencies between domain operations, you have to worry about what happens if one of the operations gets upgraded. Doesn't that cause an effect on its dependence? So it's a good question. I think we just bypass it by saying we just don't let it happen. We have another question. If access control happens below the domain operation, how can we return a 401 unless the context of the HTTP request exists that far down? Generally, informing the user about the ultimate end of their request is something I struggle with in these systems. I think that is a really, really excellent point, that you want these operations really not to, you want them to be far enough down in the abstraction of the system for it not to be written in terms of HTTP semantics. So and also I think as a follow-on is if these domain operations are queued up and they might take 20 minutes before they get to the head of the queue and then they can act, then you don't want to leave the user around for that amount of time. So I think what we're really talking about here is, yes, we want to separate the web layer from the domain operations layer. And then how do we return a 401? I mean, that is, I think the one thing that you can do is just optimistically look in the database and say this operation requires you to be logged in, and that can be now, of course, that operation may change, but if you've within the 20-minute span, and that makes things more complex. But I think it's very good to sort of think about these. How do you actually indicate whether a user needs to be logged in, and indeed a 403, whether they're actually allowed to call a domain operation? How do you let them know? In the current reference implementation that I've been working on, I do simply just make an operation return a set of co-effects, a set of effects that it wants to do. Some are on the database, like change this, add this record, delete this record, and some of them are responses to give the ultimate user, like you need to be logged in at 401. That's the way I've got around it, but of course that wouldn't work if your queue got really, really long. You have users there waiting for 10 minutes. So you have to think about a way of doing that asynchronously. John 11 says, I think the best approach is to move away from identity and use capabilities which travel with requests. So yes, I think this idea that your identity then gives you permission to, or a capability, is that then acts as a proxy for your identity. So that is done in one phase of the system, is that you allow the identity, you create a sort of a short-lived object, a capability, and that's one that's passed around the system. Joseph Winston says, given the possible impacts of a security breach, should access control be enforced by the applications? I'd argue that security should follow double entry accounting bookkeeping practices with two separate groups addressing the problem. Yes, I haven't seen that, but I guess maybe we can talk about this more in the Q&A at the end. That I think I don't really understand what you mean by double entry accounting bookkeeping practices. I do think that your security operations team, shouldn't give up. I think it should still have security at the perimeter as well. Jake Howard says, do you have any ideas, thoughts, or suggestions on how to organize people teams around the atomic architecture? I'm thinking especially about the diagram at the top of the blog post on JUXT.pro. I'm especially interested in whether code areas layers would have owners, or in different teams would share code bases. So I think one way of, I think one approach to this is that you really should have a team that are working together on the domain model and the domain operations. they're the ones that might interact with the business users and say, we want to break down the business process into a set of operations. We want to know what the operation should do. And importantly, we want to know at this point who is allowed to do it. Often those two questions should happen at the same time, because what you're allowed to do is often relevant in the context of who you are when you're doing it. And business people should give their thoughts to that early on in the process. The problem with authorization and security today is that it's in much too far down a layer. Often it's encoded as database table policies, and really we need to capture this at a business layer. So one organization is to have a domain operations team. Their job is to come up with the operations. You might have another team whose job is to make the operations accessible over through API. They might be web security, API security experts. And then, of course, you've got a great number of teams, because this just stops at the API. The point about this is to allow much of the functionality of the application system be written in services and applications that are stateless, that actually once they get the state out, they can do things like send emails, like they can do pretty graphics, dashboards, they can do forms, they can do all kinds of things. They can even do some calculations if those calculations can be then, the results of those calculations can be put back. They might make a risk calculation with some model and market data and trade metadata, work out the calculation on a given date, and then put it back. So the shared state isn't really meant to be an all singing, all dancing monolith. It's meant to just be a dumb state store, which you can put data in, but in a very principled, one at a time approach. Okay, and Jeremy, would you like to answer that question too?
Yeah, I guess when I think about these things, like the code architecture is very different or distinct in a way from system architecture, especially when you think about things like durability or availability, because you can have some very large monorepos, which huge numbers of people can collaborate with the right tooling. Anything is sort of possible. So I wouldn't prejudge the right way to build this atomic architecture. Given a set of teams and a set of tools, yeah, you can make any kind of setup work, I guess.
Okay, there are no more open questions, so I'm going to move we're just going to finish up here. So 2 more principles. If we're storing all of the operations, well, in fact, we can just log all the ones that have successfully, when I say successfully been accepted, you may have some validation rules saying, oh, this operation may have been called with the wrong data, and it can be rejected straight away. Or it might indeed be this operation is called, but the user who's ultimately calling this operation doesn't have access to this operation. So you reject quite a lot in the queue. So the operations that do get through those stage gates get to act on the shared state. And when they do, you want to put them in an event log. So I'm sort of saying, have an event log. And in fact, this event log should be at the abstraction of these business level domain operations. And too often event logs are things like, oh, well, this record was inserted into this database. This kind of change data capture idea where you listen to the things that are happening within the database itself. I think that the danger there is, again, a bit like my point about the security rules, is that you're really very far away from the cause of those changes. What we want to do is marry up the business user, what policy was applied, why they did it, even the business justification. We want our event log at that level of abstraction. So one of the advantages of breaking up your entire your system into a set of business operations is that you can then log them. And this log has a single order. There are no parallel logs here. It's just a single log. This is a kind of similar idea. This is the diagram I have on the JUXT.pro article that was mentioned, and this is really to show that, in fact, this log can be then used to trigger things downstream that might want to work on the analytical data. So, for example, you may use this log to notify somebody, hey, you know, we've just actually onboarded a new user. You should do, you know, trigger any onboarding of that new user that needs to happen, or an email that has to go out. So actually having an event log is not just good for replayability, it's a fantastic opportunity for you to just publish this downstream and to say, hey, anything that is working on data in the past can now be triggered. And so I could kind of like this view of operational data is data in the present, and yeah, you know, as soon as it happens, it becomes analytical data. And in fact, you know, in the spirit of trying to simplify these systems at a small level of kind of data volumes, there are these databases called hybrid transactional analytical processing platforms, HTAP, you might hear. And this is a direction that we're moving XDDB, our own database, in, which is really this idea that you can do, if you can do many of the more simple analytical queries in your transactional database, you just don't need two databases. And there are some movements towards, you know, columnar databases that can do analytical queries really, really well. And particularly if you've got control of time, where you can run analytical queries off on a different CPU or a different machine, but that machine has access to exact same database files as your transactional database. So we call that separation of storage and compute. So there is a way that you can bring some scalability into this design too. You mentioned a reference implementation, sorry, an anonymous attendee. You mentioned a reference implementation with co-effects, etc. Will this be open sourced at some point? Yeah, the code I'm mentioning is actually in our site open source products. It's open source. I make sure that the link to that project is in the email that gets sent out at the end of this webinar, or in a few days. Yeah. What would you change about this architecture if your domain was event sourced rather than the source of an event log? Well, I would welcome welcome some discussion about how this fits into an event sourced architecture. I think I've always been drawn towards synchronous human interfaces where people sitting there at the end of a web page, or they want to do a transaction. And so I kind of believe that you know, it is very event source friendly, in that we are really ultimately talking about a single set of ordered events. And I think you could put these operational requests, a request to do an operation on an event sourcing system. But really what we're talking about, it goes through the database first and goes through the access control layer and so on, and then it gets turned into a subset or a filtered log. But I definitely think you can build an event. This is a kind of event sourcing system, in that or it's certainly a kind of CQRS system. And Harry kindly says, enjoying this very much, thank you. At the beginning of the talk, you mentioned the pain of event versioning, event schema migrations, even in an event-driven world. It sounded like you were going to propose a solution to that problem. Well, the solution to that problem is really to say, let's not expose the messages themselves, you know, the format of the data that goes on. Let's not expose that. Let's just really say that the data, that the operations are named. We just give that operation name, like this customer was invoiced. And then if we want to change the way that that works, we can come up with a new name. Or version that operation. It isn't just really about exposing data into an event log and then expecting everybody to know what the format of that data is and never being able to change it. You can change what an operation does, but essentially the meaning is the same. The operation was done. And it sort of leads me kind of neatly to the last principle, which I want to just tack onto the end, because, you know, of course, one of the problems that we have, if you just got the operation that happened on a particular time, is that often you want to delve in and see exactly if the operation was, for example, approve loan. You might want to see, well, why was that Why was the logic of approved loan? What did it work on? Why was the loan approved or rejected? And being able to go back to the exact state at a particular time and be able to rerun that operation if you're able to put the code in this big timeline as well. I think it's tremendously powerful. You certainly can't do this today in systems where the state is distributed. I mean, you cannot freeze a very large microservices system. You just have to rely on the fact that it's kind of some organic system that will work. But again, it might be more representative of the real world. Again, I would appeal to sort of IT professionals to say our job as IT professionals isn't really to model and represent the real world. Our job is to create use technology to create systems that allow everybody's job to be easier. And we do that by creating these very powerful abstractions. So one powerful abstraction that we want to create is this idea that you can freeze the universe, that you can turn the entire universe into a value that you can then reason about. You don't have all these things happening in the realm of physics. You can sort of have reasoning in the realm of mathematics. And in order to do that, you have to create you have to turn physics into mathematics. You have to invent some very clever abstractions for us to be able to tell a story of how state flow through the system. And I think this is really, I suppose my complaint about the modern world is how many things go wrong, how unreliable everything is. And you're going to really want to be able to call up a call center and be told exactly what happened, when it happened, why it happened, and how to unfix it, or so on. And I think we've kind of lost that quality. So anyway, we're almost at the end. And I'm going to just go to the final wrap-up slide. I did want to just throw in, I felt that I haven't really explained atomic architecture in the context of a wider organization. I did hint about domains and stateless services. So I have just stolen unashamedly this diagram from Martin Fowler's blog. Actually, it was Zhamak wrote it. It was the data mesh article, and I'll add this to the notes. So this is, can imagine this as a diagram. I'm going to say it's for atomic architecture. There are 4 domains here: artists, podcasts, users, and media. Lots of services and applications that are maybe talking to one domain, maybe talking to 2 domains. They're all getting access tokens of OAuth2 and so on. But these domains are relatively independent. These domains also perhaps own their own deployment. They build it, they run it. They might own their own data analytics. They own their own API layer. They own their own security. They behave more or less like independent entities inside an organization. And I think this is the model to break the monolith. I think we should have an organization which is much more like the domain, has a central set of data, and then many applications around it, which I think are ephemeral. We're writing applications all the time. Data certainly outlasts our applications by decades. But I think this is the right mode for the future. And I'm really, really impressed by data mesh, and I would recommend people read it, which is kind of one of my recommendations at the end, which I'll leave this up as I answer some other questions. We're a little bit over time, and I hope you don't mind. We are going to carry on the call. If any of you want to stay on, I am going to do a little demo of the XTDB and site projects working together to demonstrate some of these principles. That's all. So it will be a little kind of code demo, on the command line and with Swagger and so on, so you can have a look. But before we do that, I want to just finish off by answering a couple more questions. And yeah, there's Sagar Frijalal says, in an ideal world, domain operations are really simple and do one thing and do it really well. But more often than not, we need to compose them to form a more complex higher level operation, which has independent reads and writes. Queuing these operations then seems to employ plausible. How would the atomic architecture deal with these operations? I do actually think that if you had an operation that broke down to a complex high-level operation, which decomposed to a set of smaller operations, and those smaller operations were then independently queued up, I think that breaks data consistency. So what I'm saying really is that don't have those simple small operations. I'm saying have the complex high-level operations only. Now, whether you need to, how you kind of build those out of building blocks, which aren't operations, maybe code modules or so on. I don't have an answer to that, but I am saying that even complex operations that involve multiple reads and writes on the database should happen. If they need to do things that are side effecting, like send emails, I think they should write to a database table that says, hey, emails to send, and allow one of the services or application that are clients of the state to go in and say, hey, I see that there are some emails to send. I'm going to send them, and I'm going to send another operation telling the system that I've sent these emails. Is this okay? So, or you know, another operation that might request, you know, could I send these emails that are in this queue? I want to, you know, I want to send them, and I'll report the results back to you. So a dumb system at the center holding state, and where the, you know, the domain operations can be pretty dumb too. Really, they can just sort of be reads and writes. So Steph Coetzee says, somewhat related in the sense of that teams from different domains write into the same schemaless document DB. Yes, in the architecture diagram shared. How does one know what is in the DB as time goes on? Suppose you write to a system that's seen some use. Does one have to perform an exhaustive search of all documents for a given key to see all documents that contain that key? I suppose. Yes, I think that's what we're saying, that the database really is the state system, and if you want to query what records, if you want to see what has been done to that, you look in the event log. If you want to know the current state, then you look in the database. What are the key takeaways that distinguish this approach from CQRS? What is lacking in CQRS? I think this is a CQRS. I think it's in the family of CQRS systems. I mean, it is just really, CQRS, by the way, is command, query, responsibility, separation. So just the very fact of separating commands from queries, yes, this system has, this architecture has this property. I think it just is a subset of that. We're adding more constraints that I think chime well with CQRS in order to build a more comprehensive system. So we're just, I think we'll wrap up the main webinar. If you have, thank you very much for everybody for joining us. And if you have other things to go to, if you're in the US and you have other meetings to go on to, then thanks so much for giving us your lunchtime, and we're really pleased to have you. If you're in Europe and it's coming in the evening, you have to leave, then yeah, thanks again for joining. I will just, we'll wait about 2 or 3 minutes, Adi, let Adi wrap up, and then I'll carry on with the demo for those people who want to stick around to see it.
Yeah, so thank you everyone for coming. Malcolm and Jeremy are sticking around for a quick demo. So please stay. Malcolm, when you are ready, I think that you can just dive right in.
Okay. So I'm going to demonstrate a XDDB database, which is going to start off being empty of documents. And I'm going to show you some API authorization that the system does. This is really a system that is, we've had these principles in mind for a few years. So they kind of really informed our thinking of systems, but it is a bit of to and flow. We try to build open source. We're building systems on customer sites all the time, and we're doing this with this kind of functional programming mindset. And then when we kind of want to reflect on an idea that we want to try out in the lab or in our product set, that's what we're doing. So this has started off 3 years ago as an experiment of using XDDB, which is let's call it a document database, and saying, what if those documents were all web resources? So what we had to do is say, well, the identity of each document is a URI. That was it, right? And then where does this lead us? What if the entire state of the system was in the database rather than in the code structures and in memory? So that was another thing that we wanted to experiment with. Again, that was kind of 3 years ago. It was a pandemic project. So this is what I've ended up with. I'm going to start a thing called Site. Now, Site's the code name. We're going to announce it is going to become an official product within the XT family. It integrates very well with XT. We are going to release it at such a point where it's in tandem with the new generation XTDB, which is Jeremy, do take an opportunity to mention the kind of the current that we have a new. I think by the end of the year, I think we're aiming to go into preview or alpha with the sort of new generation of document database. Jeremy.
Yeah, that's right. So XT was initially released in early 2019, and yeah, we're sort of on 1.24 now. So a lot of stable releases on the 1X architecture. But yeah, we're hoping to release an alpha of the 2X architecture. If you want more information, check out the XT website.
And this runs on the 1X architecture, but it's and you can get this today. It's at github.com/juxt-site. So this is what it looks like. I've got an empty database, so I'm going to initialize it. This is something that we can do in a Docker image. This is something you do with a new instance. This is something we got a CloudFormation template as well that can just do it for you. The point of this is it's creating a service which could be remote. It's running on my machine now, but this could be remote. And when you create it, it creates with a client secret. This is the only thing that it can give you to say, from now on, you can configure me remotely. And it has to bootstrap some difficult to guess element, which is what's called a client secret. We've only got we've got these two applications. These are two services that can talk to the central states. There's a web application, and that uses one client secret, and there's another one, which is a command line application. So I'm going to log in with that, and that gives me a access token. We used, if you're familiar with OAuth 2, we used a client credentials grant flow to get that access token. And we can do things like give me the API endpoints. So these are all of the API endpoints that have been installed and that I can call as this site user. I can find out who I am by saying who am I, and I can see a more verbose version of it. It will tell me all the operations that I'm allowed to call. So these are some of these operations quite technical because they have to do with the way the system works at this stage. But eventually these operations would be things, and I'll show you in a minute, that these would be business operations. All of these object operations are subject to a permission or capability that has to be acquired before you can call the operation. So let me then, I can also with this API operations, I can dig in to find you what that I can dig in to find this API operations endpoint. This is me opening up the hood and showing you kind of a little bit inside what's going on. This is a document in the database. It has a URI, which is this URI here. It has some methods. So I could ask it, could you tell me what methods you have? And the way I would do that is ask curl to give me the headers. I'd say I'd give an options request, and then I would give it the URL. This has given me an HTTP response saying, hey, yeah, you can do a get and a head, which is kind of implied because we support a get here, and then options. So this tells us from HTTP that, yeah, that these are the things I can get. If I was to do a get request, a normal get request, it's going to give me this in just normal JSON. I can also ask it for another header. So we'll say, could I have this in CSV? And then you can get the CSV content type. But you see there it says CSV. It tells you that the accept header. If you're an HTTP geek, you'll recognize all these HTTP response headers, but this is really demonstrating that a lot of the HTTP facilities are just kind of built into the system automatically on every resource. It's just something that you get for free. Okay, now if we go to do something more, now I'm going to install I'm going to actually install a few other things. So everything in Site is a bundle. I can find out the bundles that I have available. They're all sitting in a repository somewhere, and I can choose to add these bundles independently. They're all independent modules, and this especially is useful if I want to create a very, very small system. There are bundles here that you can build a full OAuth 2 authorization server, but for the most part, we want to have a resource server. We're going to be an API server, which allows us to create secure APIs. So we want to just make that part of the database. So I want to show the swagger of some of these API endpoints, and to do that, I need to install into here a bundle, and I'm going to call that the system API resources, and that will give me an open API resource here with some open API metadata that's kind of come in. So it's ready to serve this. We now need to no, I can do a get. Oh, by the way, if anyone was wondering why I'm actually allowed to get API endpoints rather than it giving me a 401, is because we are kind of storing the access to the bearer token in this .curl RFC file. This is really as a cheat so that you can kind of use curl without having to always remember to put this header in. But I just wanted to say that, by the way, if you thought I was kind of cheating. So now we've installed an open API. I do need to just install a login form because we're going to have to authenticate with the system, and I'm going to need an OAuth authorization endpoint. And the reason I wanted to install the login form is because I want this kind of very basic password-based login, but I can have connect it to an OpenID provider if I was to do that. And then finally, I need to I've got enough to fire up Swagger endpoint here. So this is I can say, for example, who am I? Of course, that will give me a 401. So 401 means unauthorized. The way to solve that is to click on authorize. And here we need to give the name of, well, I'm going to choose one of these, but I don't know the client secret of any of these options. I don't have that, but I do want to register a client ID called Swag UI. So I'm going to do that here. I'm going to create an system client, and it's going to give that Swag UI. So now I can authorize. I don't yet have any users. If I type site users, move that over to there now. There are no users, so I'm going to register a user, and because I am a site admin, my logged in user here, which is an application called Site CLI is able to add users. So I can say register user. I'm going to give my say Jeremy password. I'm going to type it. I'll skip to type something there. So we've registered a user now. Okay, that should be enough. So I can now log in as Jeremy. And now I've been asked, or Jeremy's being asked, does Jeremy trust that Swagger UI can access potentially his data? So, and then a whole bunch of scopes. Now, we talked about operations in the talk. These operations, if I just look at some of these operations, actually appear in a scope. I can, so let's have, I think this might be get logs. So let's have a look at that. So some of these are sitting in a scope, and so that's what this is here. We want to bundle operations into these scopes. You don't want to give the human this huge list of all of these potential operations they want to make. So we bundle them up into kind of human categories. And now I can authorize that, and we're back to the Swagger UI. This could be any application. And now we're going to execute this again. And we see, right, okay, we have 200. This should be Jeremy. Here, that's Jeremy. And then we can say, do things like, oh, get me all the users. Let's have a look at that. We get a 403 in this instance because Jeremy doesn't have the site admin role or doesn't have permission to call this particular operation. So we can fix that by saying Jeremy is now a site admin. I'm very happy, and I'm very happy using the command line. Of course, this command line is just a not a specially privileged client. It's has the same privileges of any user or mobile app. So it's just kind of to demonstrate this is all calling through an API. The only exception is when I'm looking at site find and actually digging in under the hood. You can only do that if you're running a local site instance. So I'm going to give Jeremy that permission, and I click on here. And now it gets to 200, and you can see the users. So if I was to register a new username there, register user, say a D, password, okay. And then I can execute this again, and you can see a D there. So that really is, that's kind of the end of the demo. This was just one, just if you kind of want to, if you have an open API, and I've got a few on my disk on this. So these, I've got one called Pet Store. We'll use the Pet Store that everybody hates. This is just a JSON file that is an open API description of Pet Store. So we can just install that into the install open API. It's gone in. So now we can I think we change this to Pet Store. So this is an API that's been loaded into the system. Every operation will link to some document. We haven't got those documents installed, so I'm going to have to install those. So I think it's demo Pet Store pet operations, and we'll put in some pets for fun, some seeded pets. Oh, I'm not allowed to do that because I think I have to sign. Let's log in as Jeremy. So I'm going to assign username. Yeah, I'm going to. Oh, actually, all I need to do is give Jeremy the role of Pet Store owner. Okay, and now I can log in as Jeremy. Request open. But in the part again, that was a request. That was a resource owner credentials grant there, and now I can go back to install the pets, and the pets have gone in. So you see, the developer experience is, the console experience isn't perfect. There's some better kind of error messages and so on, but it's basically a functional. It would look much better if we had a proper UI to do all that command line stuff. But again, now I can click on pets. So this is a pet store that's kind of just built in front of you. I haven't shown you the operations, but they're pretty simple. Like each operation is about 10 lines of code. And then you can try this out, execute that. Again, I'm unauthorized, I have to authorize as Jeremy. I think we can go in with, I think we can go in pet store. Okay, oh no, maybe not, because we're coming in from Swagger, right? So that won't work. We've got an error there. Because I'm showing you this with Swagger, so I have to go in with Swagger. Actually, let's do that again. Let's select all this time, go back, log out. And now I can execute these pets, and I can see the various pets within JUXT that we've seeded. We're going to build, we've begun to build a front end to this pet shop so that we can show off our all of our family pets within JUXT. But it's essentially what I've shown you is really the ability to virtually kind of start from scratch, push in an API of any design. As long as I write the operations that those methods attach to, I'm my backend is now done. So I guess the last thing that I kind of need to show you is what these operations look like. So if you just forgive me to bring up these this operation, right? Server. Yeah, let's have a look at. Yeah, so this is what an operation looks like in the database. Oh, this is the source code of it, but it becomes the database document. You've got some quite strange set of what we call triples here. These are the clauses that say whether this operation can be run by a user. So in this case, we're saying the subject, which is like the proxy, the person that represents the login, has to be owned by a user, and there has to permission has to exist that has a role. The role has to be a type role, and there has to be an assignment, a type role assignment between a role and the user. Now, this is really how we made that pet store owner thing work. What we're saying here is this can only be done by pet store owner. And then the program here that this is actually going to run in the operation is this. It's saying, okay, this is a XDDB query language. So this is a data log of the first generation. The second generation is going to allow you to write SQL here. So this just be kind of a SQL query, maybe with a few extra bells and whistles. In this case, we're saying we just want to get the dog out, and we're going to reduce. This is a functional language for closure. It's a sort of Babashka variant. But the point about this language, or any languages that site may support in the future, like JavaScript and WASM, is that the language of the operation itself, the implementation, will exist just like any other data record. It will go on the event log. It will be it will be executed. So if you were to patch or update or hotfix this operation, you wouldn't overwrite the previous version of that operation, and so you wouldn't lose the overall reproducibility of the system. So this is really kind of an extreme property that even the code behind the system is actually part of the system, part of the data timeline. And that's really what we talk about a lot in JUXT, about time being central, having one timeline for your data, for your schema, and for your code. So thanks very much. I mean, that's all I have time to show you. But again, please do email me. I've put my email. It's mal@juxt.pro. I mean, a reply to, if you see an email from the webinar, just reply to that. It goes to Dee and myself. And so if you've got any more questions, then do let me know. I do have one last final question. What's your opinion of Polylith? I don't know, but I know I know a couple of colleagues at JUXT who have worked on Polylith projects, so I can definitely forward that to them. And I generally like the idea of building blocks and not reinventing the wheel. So I'm generally in favour of these sort of things. I think the devil is in the detail. I've never had personal chance to use Polylith in anger, so I don't have a strong opinion, I'm afraid. So once again, thank you so much if you're still around. It was really nice to host you, and do write. We're very keen to hear anything that you have to say about the webinar or anything else. Thank you very much.